Hi everyone, this is Group 5, and the part of the lawnmower we were given was the handle, where several material tests were performed on this part, and also it was required for us to redesign this part and the whole push mower to a powered or ride-on lawnmower. The test methods performed are the density test, tensile test, flexural test, hardness test, and lastly the microstructure test. How the testing went. Did we face any problems on the day? Well, particularly we did not face any problems, but there could have been experimental errors introduced during the testing. Did we prepare enough specimens? For every experiment, there were 3 specimens prepared. But in order for us to have had a more accurate test performed, we could have prepared more. But due to the time limitation, we were unable to do this. Was there any equipment issues? The equipment used had no issues. Did we do enough tests? Well, we always thought that if we had done another extra test, for example like the compression test, we could have achieved a more accurate CS3 level material for the sample. In the case of compression, we could have found a value for the compressive strength where a suitable range value could have been used. The outcomes for the density test is shown here for both the direct and indirect measurement methods, where it was calculated using all the data obtained during the test. The primary outcome for the tensile test was the data of the load, extension, and the sample dimensions, where it was required to calculate the stress and strain in order to plot the stress-strain curves for the 3 specimens. The secondary outcome of the tensile test was where the specimen's stress-strain curves were plotted, and the offset yield strength, ultimate tensile strength, Young's modulus, and the total elongation data was calculated. The primary outcome for the flexural test was the data of the load and flexural extension plus the sample dimensions, in which the stress and strain was calculated in order to plot the curves for the sample specimens. The secondary outcome for the flexural test was the stress strain curves and the values for the flexural modulus and the flexural strength where it was calculated. The outcome for the hardness test consists of 3 trials where 3 hardness values were found. The surface of the sample that underwent the microstructure test at an objective magnification of times 10 can be seen here. The outcome for the surface of the sample that underwent the microstructure test at an objective magnification of times 20 can be seen here. Lastly, the surface of the sample that underwent the microstructure test at an objective magnification of times 100 can also be seen here. The material was identified to be a structural steel. The way the material was identified was we used a suitable range for the values of the physical properties, the mechanical properties, and for the composition of the sample. Well, in order to redesign the lawnmower from a push lawnmower to a powered lawnmower, we specifically took several aspects into consideration as they were so vital to the redesign. These include the power system, the power transmission, the moving system, the working system, and lastly the operating system. Primarily, when it comes to the power system, we used a small diesel engine which was used as an internal combustion power system. This engine provided all the energy needed to do the work. The main engine components included the fuel tank, the water tank, and the combustion cylinder. Well, a pull line was added to the engine to control the throttle, and the switch was connected to the handlebar. When it comes to the power transmission, it was all done by 2 power belts, where the power belts were equipped with pressure rollers. The pressure roller pressed against the belt and the power was transmitted to the transmission. A pull switch was added to control the roller. The transmission consisted of several sets of gears and was responsible for adjusting the engine speed and the direction of rotation. In the moving system, two blades were put under the mower and was fixed to the rotating disc. Using the power system, the power was transmitted to this disc, and also, in order to block any debris, a shell was preferably added to the rotating disc. In the walking system, four tires were installed, and the transmission output power was transmitted to the tires to make the mower move. The operating system was a vital part to the redesign because, in order for the mower to work properly, it had to function properly. So, what we did was we had to integrate the moving system and the working system into the handlebars, where the clutch was installed on one side of the handle and was connected to the transmission by a metal cable. On the other side, a metal cable was used to connect the rotating disc so that the clutch can be pushed to transfer the power to the wheels and blades. The figure shows a hand-drawn rough sketch of our redesigned lawnmower. Moving on to the redesign of the component, we had two things in mind. Firstly, the purpose, and secondly, what was improved in our re-engineered handle. So what was the purpose? The purpose was to provide a comfortable grip. And what was improved in our re-engineered handle? Adjustable height with a lock mode, a comfortable hand grip, and adjusting a proper and a calculated angle of the rest of the handle. Also, to provide a better material that would last longer, avoiding any fatigue failures. To tackle the height, we provided two features. One was an open socket joint at the bottom of the mower where the handle was joined to provide simple movement. In order to tackle the problem of grip and avoiding skin problems because of the prolonged usage, we had provided basic form for comfort, but with cross-link gaps with sufficient depth to provide better grip on handle. We came up with a specific angle of the handle. At the midpoint of the handle, an adjustable angle socket was provided to adjust the angle of by up to 25 degrees.